The following function is continuous at x equals 1. So to determine if a function is continuous at x equals 1, first thing we need to examine is if they're both defined, if we need to look if it is defined at x equals 1. Is it defined at x equals 1? Yes, because f of 1 would be equal to 1 plus 3. That would be f of 1. So f of 1 equals 4. And so we can write, and so f of x is defined at x equals 1. Good. So the first part takeaway, there are always 3 criteria to show. You have to show that the function is defined. Next thing to look at is if the limit exists. The limit exists if the left-hand limit is equal to the right-hand limit. So we need to evaluate the limit as x approaches 1 from the left-hand side. The limit as x approaches 1 from the left-hand side, which is less than x. The limit as x approaches 1 of f of x, and it should be, we need to check to see if it is equal to the limit as x approaches 1 from the right hand side. This is what we're checking for. We're checking for this. Okay, so let's go ahead and see if this one is at least true. So from the left hand side, to evaluate the limit as x approaches 1 from the left hand side, what we're finding is the limit as x approaches 1 of x squared plus 1. This is the left-hand limit, all right? But this is equal to, when you plug in 1, you get 1 squared plus 1, you get 1 plus 1, and 1 plus 1 is 2. Nice. So then now we need to evaluate the limit on the right-hand side. So evaluating the limit on the right-hand side, limit on the right-hand side is going to be x plus 3. Then you plug in 1 right here. Plugging in the 1, we get 1 plus 3. And 1 plus 3 is equal to 4. But guess what? These two limits are not the same. These two limits are not the same. They don't work out to be equal to each other. So in this case, we can see that the left-hand limit is not equal to the right-hand limit. They're not equal. They're not equal. So since they're not equal, then we don't even need to go any further. The function is discontinuous at x equals 1. So the function is discontinuous at x equals 1. And that's all we have to do. Soft. Discontinuous at x equals 1. Nice. Out of the way. Done and dusted. Let's go to another example. All right, this question says, determine if the following function is continuous at x equals 1. To determine if this function is continuous at x equals 1, again, we need to check if it's defined at x equals 1. Yes, it is defined, because g of 1 is going to be equal to work out g of 1 looks like just the square root of 1 square plus 3. And so g of 1 looks to be equal to 1 plus 3 is 4, the square root of 4 is 2. So clearly we can see that the function is defined at x equals 1. And so we can say g of x is defined at x equals 1. Yeah, man, so g of x is defined at x equals 1. Now let's work out the left-hand limit. So to work out the left-hand limit, we need to work out the limit as x approaches 1 from the left-hand side of g of x. And the limit as x approaches 1 from the left-hand side of g of x is going to be equal to the limit as x approaches 1 of, which one is the left-hand side? The one that is less than or equal to 1. So that is the square root of x squared plus 3. Square root of x squared plus 3. And so plug in 1 now, and we're going to get 2. So the limit from the left-hand side is 2. Let's check out the limit from the right-hand side. So the limit as x approaches 1 from the right-hand side, limit as x approaches 1 from the right-hand side, that is going to be equal to the limit, that's going to be equal to the limit as x approaches 1 of, that looks like x plus 2. So x plus 2, and we'll plug in x as 1 right there, but 1 plus 2 is 3. Now these two are not equal. Since those two are not equal, we can tell them that the left-hand limit is not equal to the right-hand limit. The left-hand limit is not equal to the right-hand limit. That's if you want to write it out in words. I generally don't recommend you write it out in words. You could actually just write it out in symbolic notation to tell them that the limit as x approaches 1 from the left-hand side of g of x, this is just it in words, in symbolic form I should say, and you tell them that this is not equal to the limit as x approaches 1 on the right-hand side. Have to tell them that. You have to. So once you tell them that that is so, and so hence the function is not continuous because the 3 conditions are still not satisfied. So since the 3 conditions are still not satisfied, we can tell them hence the function is discontinuous at x equal 1. Function is discontinuous at x equal 1. Easy, soft. It says determine if the following function is continuous at x equals 0. Straight away, it is not continuous at x equals 0. How do I know that? Straight away, I know that it is not continuous at x equals 0 because look at this. As we can clearly see, how do you find g of x? We can't find h of x rather at x equals 0. H of 0 is undefined. H of 0 is undefined. So since h of 0 is undefined, condition 1 don't even satisfy. And so h of x is not continuous, or you can say discontinuous at x equal 0. Now, if you were to actually find the limit on the left-hand side, you get 2. The limit on the right would be 2. The limit would be there, but it's just that the function is undefined in this example. Easy, soft. Let's look at another question. Function is continuous at x equal 1. So first we need to find if g of 1 is good. G of 1 is going to be 3 times 1, which is equal to 3. Okay, g of 1 is good. Now let's check this out now. This is just g of 1. So criteria 1 is satisfied. Let's check out criteria 2. For criteria 2, what do we need? We need the limit from the left-hand side to be equal to the limit from the right. So the limit as x approaches 1 from the left-hand side, which is minus of g of x. Let's work this out. That is going to be equal to the limit as x approaches 1 of, which one is less than 1? Less than or equal to 1 is this one, 3x. So using 3x in this case. All we're going to do now is directly plug in x as 1. Plugging in x as 1, we get 3. So that's the left-hand limit. Let's look at the right-hand limit now. The right-hand limit we need to find is the limit as x approaches 1 from the right-hand side of g of x, right-hand side of g of x, and the limit as x approaches 1 from the right-hand side of g of x, that will be equal to the limit as x approaches 1 of 2x plus 1. Yeah, man. So finding the limit as x approaches 1 of 2x plus 1. So all we have to do now is plug in x as 1. Plugging in x as 1 and we get 2 plus 1 and 2 plus 1 is 3. Now since the left hand limit is equal to the right hand limit, we are Gucci. Nice. We are Gucci. Nice. And so we can conclude, yes, we can see that the limit, we can therefore write now that yes, the limit as x approaches 1 exists since the left hand limit equal the right hand limit. So the limit as x approaches 1 of not f of x, limit as x approaches 1 of g of x is equal to 3. So is the function continuous? Yes, the function is continuous because guess what? We need to check the third principle to see if it equals g of 1. Is it equal to g of 1? Yeah, man, but this equals g of 1. Once the limit is equal to the functional value at that point, then it is continuous. So we can write hence g of x is continuous at x equal 1. Easy question. So question here. It says determine the value of p if the following function is continuous at x equal 3. If it is continuous at x equal 3, then the limit from left is equal to the limit from the right. So all we have to write down is that the limit as x approaches 3 of the left hand side, which is px squared plus 3, we know that this is clearly going to be equal to the limit from the right, which is the limit as x approaches 3 of the square root of 4px plus 9. The square root of 4px plus 9. This is what we do now. So all we have to do now is plug in x as 3 on the left side. So we get 3 squared is 9. So we get 9p plus 3. And that's going to be equal to, plug in 3 right here. We get 3, that's 3 times 4 is 12. So that's 12p plus 9. So all I have to do now is bring over 9p over here. Bringing over 9p, I think that becomes 3p. Bringing over 9 over here, that becomes minus 6. Then all I have to do now is divide both sides by 3. Divide both sides by 3 in this case. And so we clearly see that p equal negative 2. That would be the value of p in this case. Easy, soft. P is negative 2. Yeah, man. P is negative. Determine the value of p if the following function is continuous. If the function is continuous, then what do we know? Then we know that the limit from the left is equal to the limit from the right. It always comes down to that. So the limit as x approaches 0 of sine 2x over x, limit of sine 2x over x, we know that this is equal to the limit as x approaches 0 is equal to the limit as x approaches 0 of x squared minus 4xp over x. Now, first thing and foremost, the limit as x approaches 0 of sine 2x over x. We know this part is 2. Then, the right-hand side, we can factor out a x. And so we're evaluating the limit as x approaches 0 of, plugging in, well, cancel out one of the x, that will become x minus 4p. This is what we end up get. 2 is equal to x minus 4p. So plugging in x as 0 over here now, because what I did was cancel out a x from the denominator and the numerator. That's all I did. So plugging in x as 0 here, you would get minus 4p is equal to 2. And if minus 4p is equal to 2, we just divide both sides now by, of course, negative 4. Divide both sides by negative 4. Dividing both sides by negative 4, we end up with p equal to negative 1 over 2. Nice. P equal negative 1 over 2. That's what we get. Nice. And that's how we do these questions. Easy stuff.